And we're back. It's COMP123. It's the summer 2016 semester. It's programming 2, of course, week 3, part 2 of our broadcast. And I wanted to pause it there for a couple of reasons. One, I take a bio break. 2, is because this is a great place to stop and look at this structure. So we have 2 things: private variables that we hold our data in, and public properties that I use to access the data, whether I want to read from it or write to it. Okay? This is the structure that I want you to use all the time. Private instance variables, public properties. All right, let's make one more thing. Okay? Another little structure. I want to make something called a constructor method. Okay? A constructor method is like a regular method, right? Like a method that has the name, a name, and perhaps returns something or whatever, right? But it has the same name, the same identifier as the name of the class. Okay? I want you to think about this method as triggering or running, executing, as soon as I create an object from the class. All right? So it's almost like it runs. As soon as I create a new object based off this blueprint, I make a new person, something happens as soon as I make it, right? It's the first thing that triggers as soon as I instantiate my objects, right? Sometimes this is great from a initialization perspective. If I want to initialize something right away in my class, it's going to trigger as soon as I instantiate my object. So let's do this. Let's make a new public constructor method, and we're going to use the same name, so person. And notice that I'm just going to do one of these, right? So it looks like a regular method, right? But I don't need a return type because the constructor can never doesn't return anything, right? Let's put some comments here so we can see what this looks like. We're going to say, remember we did this before with comments. Proper comments this time is the way like this. For one of these. And then inside here, we're going to do something like this. We're going to say, this is the default empty constructor. That's what this is called for the person class. And then we're going to do some decorators, right? At constructor, we're going to use person, right? That's just the empty constructor. Okay. And it doesn't take any parameters, so that we don't have, if it was going to take parameters, we can put them in here too. But this one doesn't take any parameters. It's called the empty constructor, or the default constructor, right? And I'll say, that's why it's called, I kind of put them both in their default empty, but it's really called the default or the empty constructor. Okay, so that's what we have so far, right, for our person. This is our class, right? So far it doesn't do much, just has a name, right? We need to do the next piece, which is instantiate an object. Right now, it's just a blueprint. Doesn't mean anything. It's just a plan that we have in space, right? It's hovering around. We don't do anything yet with it unless we actually instantiate it. We're going to use our program class, our driver class, this thing, which is a separate program. We're used to doing this in here anyway, right? All of our stuff has been done in here in the past, right? We're going to use this program class to instantiate an object based on the person class. When I say instantiate, I mean breathe life into, create, right? How do I do that? I need to use the new keyword, right? So I'm going to do this. Typically, we make a data type, which is in fact what we've done. We've made our own custom data type called person, right? I want you to think of it that way as well, right? A complex data type that has a name property, right? So I want you to think of it this. If I declare a data type like a string, I would put string first and then whatever it is, right? In this particular case, we want to put string. We want to use person with a capital P. Let's try this out. Person. Notice how we can see that person exists, right? And it says person is a type which is not valid in the given context. But notice how it says COMP123 da 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 person, right? The next one is we're going to make the name of our object, right? We're going to use, so normally when we do classes, the name of our class is capital first letter. All right, that's a typical. That's our best practice, if you will, convention. Name of a class, capital, right? Capital first letter for our you know, for how we're going to call the class, right? And then for the identifier, and then we're going to also declare the object name, and I'm going to use lowercase person, like P with a lowercase, like this. It looks funny. Person is a data type, and lowercase person is something else. It's almost like saying string, capital S, string, right? And string would be the data type. We can make some. We can call this something. We can call this something else. And if it really bugs you, right? We can call this a name, the name of a person, like Tom. Fine too, right? Or name, put your own name in there. But the identifier person is there. We can use whatever we want, right? So that's the first part. Now I could stop there, right? And it's going to say, well, okay, you've declared the shape of your variable person as a data type with the blueprint of person. But I haven't instantiated an object yet. All I've done is define the shape. I've told the compiler that I want to create it's almost like me creating a string without assigning a value, right? I can't assign a value to my custom data type without using the new keyword. Okay, how do I do that? And you know, you can have it separate like this. Person is equal to a new person, right? That's the separate way. What I'm saying is, make a new person. When I use the new keyword, I'm going to instantiate the object. Now, instead of it being here like this is nothing. This is just a person variable, right? With a shape that's the same shape as the object, but it hasn't been created yet, right? It's a reference. It's a reference. It's pointing at the person container. It says, hey, this is probably going to take this shape, right? But here, when I use this line here with a new keyword, I instantiate, I breathe life into this new person. All right? Okay, cool. Well, once we've done this, and by the way, you'll see it quite often done in one line, like this as well. That's perfectly fine. You can declare and instantiate all at once. Right? I'm just telling you, you can break them up. You don't have to do it this way. All right, so let's just comment here a little bit. So this is create a new instance. I say instance, it means that new object of person class, right? Let's put some comments in here. This is my main main method for my driver class, right? So, the main method for our driver class program, right? And this would be at method. Sorry, at construct. It's not a constructor. It's at method, because the constructor would have the name program, right? It doesn't have the name program. It's main. This is the main method. It's not the constructor method. Constructor methods always have the same name as the class, right? So at method main, right? And it has some arguments, right? What are the arguments? There's a string array. I can put this in there. At param, or parameters, which is a string array, right, of args. That's what it is. We only get this access to this parameter from the console if we were ever going to make an executable file that we'd run in the console, which we probably never will in this course anyway, right? But just defining how it would look. This is our program class. Let's add some other comments here. So commenting style, right? This class is the driver class for our program, right? Actually called program, right? And we're going to say at class program, right? It doesn't have any methods, so it doesn't have any properties here, so we don't have to put anything as a parameter list here, but we could. So you see how we're commenting. Let's do the same thing for a person class. comments, right? We have our person class. We can do the same thing. We can say, it's a little different, right? Because we have our person class has properties and both private instance variables and properties. Now, your question is going to be, how do I comment that on the top, right? Well, again, it's something this class defines a generic person, which will never exist, right? Not true. There's no generic faceless person with 2 arms and 2 legs. Everyone looks different. Everyone is unique, right? Okay, so we're going to say at class person. At parameter, we have some, instead of parameter, we have property and variable, right? So I would refer you back to the, if I go back to UEDoc, right? I look at UEDoc because we're using this as our default way of doing stuff. And if I look at syntax to see what it looks like for class IO, constructor, if you had other things in here, methods with return types, we don't have any of that. Here's some properties, right? Well, we do this for each property because remember, it's like a method, right? Even though we're, when we define stuff, right, as an example, we define things as variables, instance variables. Think of those as our parameters or our, part of our, our class, right? Let's go through here for some other options here. Required. Here's param, right? At param string, and throws and for and types and private and protected and so on. You can see that this is stuff we can put in here. Requires and default. This is like, if you look through here, there's some great ways of documenting, and I really would like you to use some method of documentation, and that's why we're referring to UEDoc. We could have made it any other method of documentation, but if you learn it this way for C#, it'll apply to JavaScript and almost Java as well, almost the exact same stuff, right? So that's why I'm using this, not because I want to just do it for our class, so that you have some best practice or convention that we're going to use across different programs, right? Okay, let's do that. So we can say something like for our class, we can have a parameter or a variable, instance variable, member, field, if you want. You can make whatever you like here, by the way, because that's what these are called. Sometimes these are called fields. Let's use the word field. There isn't any, but we'll make it up. And again, this is just a best practice, right? And one of the fields we have is underscore name, right? What it is, which is a private instance variable. That's why we're calling it field. Field means that it's an instance variable. Underscore indicates it's private. Type is string. Okay, so that's the one field we have. And we also have a private property, which we can also, use. So this is our kind of when I say public properties here, you can kind of use another separator like this. Take a look, right? And here's some other stuff we can do too, right? We can kind of use some separators to make it more interesting for us so we can see them like this. It's okay. Kind of decorates our code a little bit, right? And notice that in our public property here, we can say, same kind of idea. We can go kind of like one of these, and we can say something like, this is a property for our name field, right? Because usually properties public property is linked to private data fields like name. Okay, so we're going to say something like at property name, right? And normally it's the string type is important to put in there too. String usually kind of matches what we say here, right? And we can make this, it's public, right? So we know it's a public property. We can't make private properties. Typically, we don't do that. Protected we can use too, but typically not. It's usually public properties. All right, questions so far? We're just documenting, yeah.
Yeah, I just have a question about the private string.
Here?
Instance variable.
Yeah.
I'm just curious of why you do that. You said something about black box earlier, and you're saying, I was kind of confused about like.
One of the things with classes and objects and this hierarchy is the idea of information hiding, right? you're going to hear about this again, right? So information hiding is not the first or last time you're going to hear about this concept. It's almost like a pattern, a programming pattern, where you want to hide the stuff that's not necessary for the user to know, right? And so our data, where the data is being held, underscore name, is something that's private. So no user can directly access the data. They're going through a method to do it. Why? Because I could add inside, see that this getter and setter have these curly braces, right? I can add other stuff in here that happens when I'm accessing both read and write. An example of this would be if I want to set something directly, right? I could do that. I can just, if I made this public, all I can do is expose it to the real world. And then all I have to do is I can write to it, read from it, like I do any variable. But when I read and write from a variable, can I do something else at the same time? Like when I'm reading and writing, the answer is no, right? If I actually say, if I make an equals operator and say this variable is equal to a string, whatever it is, it's done. I assign a value, right? Here, before I assign a value, as an example in the setter, I can do something else, like write line out. Every time I assign something, I write something. So think about your access modifiers or your accessor methods as actual methods that you can have one or more lines happen all at the same time while I'm reading and writing. So I can keep track of that's happening. From a debugging perspective, this is awesome, right? And also to do multiple things.
Okay, so it's not kind of like that was my question, thanks. But like, so you have the private instance variable, then you have the getter setter. So like, I'm just kind of curious about like the return this underscore name. So that would, what are you doing now?
I'm glad you asked. So here's my name, right? But I use the this keyword whenever I want to access any data, any property, or any instance variable, and any property, and any method that's inside of my class, not outside of my class, inside of my class. I want to use the this keyword. So if I have a method that's called say hello, right? If I want to access that method or call the method inside of my class, right? I want to say this dot say hello, right? And if I want to access my name, this instance variable, I'm going to use the keyword this dot underscore name, and then I can assign something to it, right? Or I can return it. What I'm doing here is I'm saying when I use my getter, right? My getter is going to say take the value that's inside of my underscore name private instance variable and return it to the where I'm calling it from. And I got to show you in action before you understand how this is. So let me show you what I'm talking about. And the other way is if I set it, the keyword value means whatever value I assign, set that value, whatever the value is, to my private instance variable that's up here. Okay? So this is almost like my gateway. Basically, it's, you know, when I come in to when I access the class, the data in the class, I use and if I want to get something from it, I use the getter. And if I want to write something to it, I use the setter. I want to set a value inside my class or my object, or get a value. Set a value, get a value, right? I never want to use the direct instance variable, you know, itself because of the limitations I talked about before. Like you can't do anything about it. You have direct access, and it's almost like having my hands inside the engine when I'm driving, right? Or my hands inside the, you know, the furnace. I want to put my hands in the furnace and then turn the furnace on, right? Bad things can happen, right? And that's why we want to control what comes in and out of the class, the object, and that's why we do this. It's almost like a sentinel, or if you want to talk about, like I said, a middleman, like a butler that says, yes, how can I help you? What? You want to pass information to the variable? Sure, give it to me. I'll pass it for you. But you never talk to the variable directly. Think about the variable as like a superstar, right? Like a celebrity, right? You never can talk to a celebrity directly. You got to go through a middleman. That's the property. Okay? All right, let's, and there's reasons for this. We'll talk about later on. So now I've got everything, all the piece parts. I've got my private instance variable, I've got my public property, and I've got my default constructor, right? Okay, so I've saved everything. I'm gonna go in my program now, and I wanna test it out, right? So take a look at what we're doing here. Person is equal to new person. Yes, that's fine. And then I wanna assign something to the person, right? So here's where I'm going to start going stuff. My person is now an object. It's not a regular data type. It's not a string or whatever, but it has a name. So this is one of the ways I can assign the name for the person. Person dot, and then take a look at all the stuff that's available here. you're going to see some stuff that's always available. ToString, get type, get hash code, and equals. And then there's our custom property. Take a look, called name. If I kind of hover on this, it says string person name get set. See, that's the code. So because we've made our public property, it's available through our person class, our person object, right? So our person class, we say that, and this is our person object. The object is an instance. It's a thing that I've created from my blueprint. It's separate. I can have 10 person objects with different identifiers, person 1, person 2, person 3, person 100, whatever. But they've all been created from that blueprint, that single blueprint of that class. The class is the plan for my person, but I can have many people, if you will, right? We're going to get there. If I was going to make many people, I'd make a people array, an array of persons. I know, I don't want you to kill yourself, but it would be going like that. I can make as many different kinds of arrays. I don't have to make a string array. I can make a person array. All right? Huh?
Or a list.
Yeah, list is easier. So person.name, right? So if you notice, my name, because it was capitals, is name, is equal to, and I can say something like Tom, right? Okay, cool. So I've set a value, and if I build this thing out, let's say just build, you can see that I'm not going to get an error. It's going to build, succeed, right? Now here's the problem. I have no way of knowing, absolutely no way of knowing if I've actually set this value. So I need a way of checking it out, right? So let's write line now. So we'll do something like this. We'll say, now this is an example of the setter, right? Set a value, you know, to the person property or in the person property. I want to say in because it's a container in the person property. The name property of the person class. Okay, so I'm setting a value here, and then the name is going to be, the value is going to be carried through the person property, the name property into the private instance variable. It's going to be carried through. I want you to think of it passing through that gate or passing through that butler, whatever you want to call it, right? It's almost like a middleman. I'm taking it. Thank you. Give me the value. I'll let them know. I'll let Prince know. Sorry, Prince is bad. Prince, you know, I love Prince. Anyways, but I'll let Madonna know as an example. I'll take the value. I'll take your number and I'll give it to Madonna. Right? No problem. Maybe she'll call you. Right? A middleman. That's what it is. Right? To talk to your celebrity. Yeah.
So the name property after the person name, the variable that you created, or the object, sorry. That's where you put the get. So like the dot name would be this dot underscore name, like originally where it's coming from.
Okay, yeah, I would if it was exposed, it would be person dot underscore name.
I'm saying that's why you made after you made the private one, you made the public getter setter. So the name part is the this dot underscore name. That's where
correct.
Right?
That's where it's going. That's where it's where it's being carried into.
And the setter is
this is the setter, right? So this is because I'm setting a value. I'm setting a value with the equals operator, right? I'm taking the equals operator. I'm taking the value on the right side of the operator is my literal, or it could be a variable, right? And I'm taking this literal value and dumping it into my name property, right? And it goes, because I'm assigning it, right? When I go back to my person, when I assign a variable, it happens in here in the setter. This is where things are assigned to the that's where it goes, right?
So the name comes from the one I get, right? So the dot name comes from.
If I actually print it out, if I was going to show what the name is, I use the getter. Here's where I'm going to do this. I'm going to use the getter. So get the name value, right? And then kind of print it to the console and print to console. I say print because print or write is the same. So console, let's use CW, console.writeLine, and we'll say person.name. That's a different use, right? One sets the value, and this one gets the value, right? I set it here, and I'm using the same syntax, .name. I'm using the dot accessor. Whenever I use the dot, I access properties and methods of a class or an object, right? So I'm using the dot to access the name that's inside my person object, right? I'm using the dot to access the name that's inside my person object. Here, though, I'm using the set accessor because I'm using the equals operator to assign a value. And here, there isn't any assignment here, right? I'm getting the value because there's no assignment. It defaults to the getter. So if I don't assign something, I use the getter. If I assign something, I use the setter. Lots of words, right? Let's check this out and see if it works. So I'm gonna kind of save everything. And then I'm going to Control F5 for start without debugging. And you can see that the value I get back is Tom, right? So I saved it inside the class. The class acts as a container. And now I'm getting it back from the class, all right, from the object, right? Questions so far? I want to go slow on this one because if you don't get this stuff, you'll be messed up for life. No joke. I mean, every time you program from now on, you'll blame Tom, right? So I don't want that. It's really important. This is like, you know, make or break day, right, for you to understand this stuff. So ask your questions. Yes?
So the name is kind of like the attribute from class then, right? It's like
the name is the property. I want you to use, yeah, let's use the proper, you know, the way we talk about things. I want you to use the name. It's not a method, it's a property, right? Now I want to try something else. Okay, I want to show you something differently, right? Let's go up here, and could I make this private, you know, string? I could make this public, right? Let me show you the difference. So example, when I type the word in my, before we do that, in my program, when I use IntelliSense, right? Microsoft IntelliSense or code hinting to find all methods and properties that are built into my person class, right? I just type the word, or my person object, I type the word person, or the name person, or the identifier, dot, and then IntelliSense gives me a bunch of stuff. Notice that we have some built-in values, like equals, get hash code, get type, and toString, right? Okay, toString. Those are built-ins. Those are built-in methods that are part of my all objects. Okay. But that means that even though I've written a custom class called person, that there is a generic class out there that's hanging out, right, called object, right? And all classes across all C# code ever is inheriting, and we'll talk about inheritance another day, from the class object. And that's why we have access to these additional features, equals, get hash code, get type, and toString. Okay, that's why. Not because I've defined them. I haven't defined equals as a method, or get hash code, or get type, or toString. And notice that we have a different symbol for methods compared to properties. Properties has the wrench, right? Symbols has this really weird box, like this three-dimensional box, right, which is like a method. All right, so, you know, method, property. We've only defined name, right? And that's why it's the only one showing up here. Let's expose underscore name to show you that it can be done. Bad practice, ladies and gentlemen, but it can be done. Let's try this out. So we're going to erase this for a second. I'm going to go back to my person blueprint, my person class, right? And instead of making this private, let's make it public. When I do that, right? Now, nothing else has changed. I didn't change my underscore for now, but I'm going to keep that there so you can see it. And if I go back to program.cs and I try it out, if I say person, here's my person, now I have two, right? I have my name and I have this. Take a look at the difference between one symbol and the other. It's hard to see. I'm going to bring it up here so you can see it. This is a different symbol here, right? One is this, right? And the other one is this, right? Look at how it says it calls itself field, right? Or instance variable, right? It's a different thing, and Visual Studio is smart enough to know the difference between the two, right? One is a property, the other one is a field, right? We don't want to use fields, but we want to expose fields to the outside world. That's like, you know, we're showing our underwear, you know, that kind of thing. We don't want to show that. We want to show our outer clothes, and our outer clothes are properties, right? That's what I want you to think about. Okay, so two different things. So this is bad form typically. However, there are occasions to solve a problem that we may want to expose a public field to solve a problem, usually in a workaround. We have a problem we can't fix, public field, right? You want to do some, so you're going to do some debugging, public field. When you're done debugging, private. We turn it, put it back into the closet again, right? And the reason for that is because we have no control. If I want to do this, when I expose this, it's the same thing. If I turn this to, Mark as an example, right? Let's use another name. And if I do a console.writeLine again, let's try this out so you can see the difference. I'm using the same thing, right? Here's something, person not name, right? Same one, same getter, right? Same getter. But one way, I'm setting a value with my field, and this way I'm setting the value with the property, just to show you the same thing. So you understand, but I'm still using the getter for both times, right? Let's see how that works out. Control F5, Tom and Mark, right? Same getter, different ways of setting, right? And don't recommend the second way at all, unless you want to solve a problem you can't solve with a property. Okay, I'm going slow like this to get you to understand, right? All right, it's different kinds of properties, right? As an example, name would be a property that is accessible. Both there's a getter and a setter. Then there's also only getter properties, which are called quote-unquote read-only type of property. We can only read from something, but we can't write to it. Okay, let's try that one out. How do I make it? Let's make another property. So we're going to go back to person class, and right now we only have one instance variable, right? And if I took away this setter, let's take away this setter for a second, right? So boom, 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 this is gone. How do I take it away? Let's just comment it out. So one of these. We're going to put it in stasis for a second, right? There we go. We've commented it out. I'm going to save this up. Now I only have a uncommented or working getter. It means I can get values, but I can't set them. Notice how I'm going to have a problem here, right? Where I can't use my setter at all. I can't use it because it says property or indexer person.name cannot be assigned to it. It is read-only, right? All I've done is take away the setter, and all of a sudden it becomes read-only. In fact, if you look at this, right, it just shows one part, get. It doesn't show get set. In order for me to do, writing and reading, I need to have both the getter and the setter methods, written for my class, okay, or for my property. Please ask me your questions. There's bound to be questions. There's bound to be misunderstandings. Let's go with him first. What is the use of only a getter? Where I want to protect the values that I put into my class, right? I only want people to read them, but not change anything. Like for example, I don't know, some value that's that you want to get from a class that's that's calculated, right? I can get the value, it'll be calculated, but I can't set the value because the value needs to be calculated. Like example would be something like annual salary, right? I want to calculate my annual salary based on my annual on my wage, right? Whatever my wage is and the number of hours. So I can get that, but I can't set it, right? I'm making it up. Or some other value that you don't want to, you want to change, like the number of turns in your game. Let's say, for example, you have a fixed number of turns in your game that you're making. I have 10 turns, right? After 10 turns, the game's over, right? I can get the number of turns, but I can't change that. I can't set the number of turns to 5. Or I have a number of lives. I only have 5 lives. Can't ever get more than 5 lives. Can't set the how many lives my player has. He always has 5, right? And only things internally can happen so the player loses lives or gains them. I can't set them outside of the class. There's reasons why you want to have, and we're going to talk about these later on. So getters only. You can also do it the other way. You can always have just a setter, but that's weird, right? Why would you only want to read something, write to something, but you don't care about ever reading to it again? It's kind of weird. So we can do it, but we don't do it, right? There's almost never a time where I'm just going to set a value but not read from it. It's just letting you know. So there really isn't a case where it's write only. We can do it, but very rare. Questions around getters and setters. All right, let's take a look at your assignment for a second, and I'm going to put this back the way it was. Let's do this again. Oh, by the way, sorry, before we go there. Because we've exposed my person.name _ name, even though this is, I can't do it because there's no setter, right? Or there's no, because I only made it a getter. I can still do this, person.home underscore name because it's there, it's exposed, right? So I can still do this piece, right? No problem. And there's no error. Here there's an error because I've taken away the reason to write to it. All right, let's put it back the way it was. So save, go back to person.
Any public variable doesn't need any getter and setter.
There's no public variable that we'll ever use. We'll always make public properties. So in the person class that we have,
So if it is public, we don't need the getter and setter.
we don't need the getter and setter, but we would never do that, right? So I'm going to make this back to private, right? Because private fields, again, these are instance variables. Another name for them is fields, right? Fields are instance variables. And it's actually in your documentation. If you actually go up on the PowerPoint that I put up on eCentennial, it'll show you this stuff that I'm talking about right now. We're going to go over it too as a review. So let's put this back the way it was. So we're going to enable the setter again. We're going to take it out of stasis, out of its icebox, right? Okay, good. Everything's running again. One thing I also want to talk about is, because we've created our getters and setters, is the idea of initializing thing with the constructor, right? Right now we have something called the empty constructor, which doesn't do anything. But let's suppose that I initialize a name, something, a value in my field. There's two ways I can initialize a value in my field, right? In my public constructor. One way is to just access the field directly, like this dot underscore name, right? Because it's available inside my constructor, inside my class, because it's a member of my class. It's a field that belongs to my class. So I could do something like this. This underscore name is equal to unknown name. We don't know what the name is, right? Unknown. How about I actually put in what it's supposed to be? Unknown name, right? I could do this, right? So I initialize it when I create my person. I can initialize the name field like this, right? And then if I was to initialize it in my person constructor, remember the constructor triggers or fires whenever my person object is created. So whenever I instantiate a person object, the one thing that always triggers, always, is my constructor if I have one. By the way, even if we don't declare one, if I don't declare an empty constructor like this, it's declared for us, right? By default, it's just empty. There's nothing inside of it. So if I use the new keyword and I don't have an empty constructor defined like this, there's always a default constructor created for me, right? I always need to construct or create an object. And you're going to ask me, some of you might ask me, what about the destructor? Yeah, there's a destructor too, but we never ever use it, ever. And the reason for that is, just to put it out there, and I'll talk about this very simply, is destructors were always used in the past with C and C++ because we wanted to clean up our memory. We wanted to do memory or garbage collection is what it's called, right? So we want to close down an object, right? So we destruct it, kill it basically, right? We don't do that anymore. We want to close down an object, or if it needs to be destroyed, we let the system do it for us. Because C# and Java and Swift and many languages out there have something called automatic garbage collection. That they just go through and destruct everything for us. And if we do things by hand, we destruct things by hand with a destructor, right? Sometimes it can cause cataclysmic effects on our code and crash our system. We don't want that to happen. So we avoid destructors, typically, right? And I'm putting it like that so that way you guys never try and say, Tom, I want to use destructor. Don't do destructors, don't use. Not an object-oriented programming, yes, typically.
Curious, like, when you create an object that already creates a constructor for you, why would you have to create another constructor in your class?
Because you may want to do stuff in the constructor, and we'll talk about them, like pass variables into our constructor, right? Like initialize certain things. You know, we can do stuff, instead of even using just a getter and setter, we may want to use the initial, we might initialize our fields or instance variables through a constructor first. And then we can modify them later. Otherwise, it's too many steps. It makes it cumbersome if I have to instantiate an object first and then go through and then initialize all the fields, right? Doesn't make any sense, as opposed to I can declare my constructor and initialize everything at the same time. An example of that, if I was going to make a rectangle. A rectangle has length and width, let's say, right? So I don't want to say, you know, my rectangle is equal to new rectangle, and then down there say my rectangle dot width is equal to my rectangle dot height is equal to whatever. I don't want to do that. I want to be able to do it right in the constructor. So I would say something like this: my rectangle is equal to a new rectangle with a height of 400 and a width of whatever, and a depth of, if it was a prism of some kind, right? Okay, so that's why we use the constructor for. Typically, we can have more than one constructor. We can have, remember we talked about overloaded methods last week? That's why we talked about them. So you can see them here, because I can have many constructors. I can have a constructor that's empty. I can have a constructor with more than one variable that I pass. We're going to talk about that later on. Won't be today, it'll be next day. All right, so we got a simple constructor, and it's going to pass in a value to the name field, right? Or the name instance, the underscore name instance variable. We're just going to call it name. When I talk about a field that's private, we're just going to say name field. That's the way we're going to talk about it. But I want you to always look at the underscore as required. So whenever I do an assignment or a lab, private instance variables underscore. Private methods, we might have some private methods, are also underscore, okay? Public methods, capitalized. Public properties, capitalized, right? This is just convention we're going to use. And I want you to take on this good practice. So when you go to the next course, you have a feel for doing everything. And by the way, if you take any courses with me ever, I'll use the exact same stuff in Java, JavaScript, C, C++, Python, whatever language, Swift. Doesn't matter what I program in, I use the exact same methodology all the time. Why? Because another programmer that looks at it and goes, oh, that's private. Oh, that's public, right? Okay, let's go back to this because we're timing out. So I want to run this thing, and so I create the, when I instantiate my object here, now because I've added in a default value in my constructor, I've initialized my name field with unknown name. Before we even assign something like this with person named Tom, I want to show what that is. So let's just take this, this one here, console.writeline, and let's put it up here, right? And see what we get before we even assign anything. We haven't assigned Tom yet, but we've instantiated it, and see what happens with the constructor. Now, as you would think in the constructor, here's Control F5, right? Unknown name comes up first because that's what's instantiated first. As soon as I instantiate something, my constructor fires right away, triggers. As soon as I instantiate any object of any class, in any language pretty much, my constructor always triggers first. I can have more than one constructor. In this case, this particular constructor, because the default constructor always triggers first. It's like the key thing, the start method of all other methods inside my class. All right, cool. So that's one thing that it does. So I can do it with my constructor. Okay, here's another thing that I can do with my constructor. So I can create an empty constructor, and we're going to make another constructor here. Let's try this out. I'm going to copy this whole thing up to here, copy it, and go in here like this and paste. Notice that it's going to give me a bit of an error because I already have the empty constructor, right? It's exactly the same. It says this type person already defines a member called constructor, CTOR, right, with the same parameter types. That's what it is. So I want to add another parameter type. I want to take the name of the actual person. So I'll say string, right? And now I'm going to do something different that's going to really confuse you. Name without an underscore and name without a capital name. By the way, you'll see this many, many times. This is a constructor takes name as a parameter and passes it to the underscore name private instance variable. Okay, person. Constructor is the same, constructor is still person, but my parameter list is different. At param takes a string, and it has, the string is a name, right? Now you're going to say, whoa, 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 what's going on here, right? And now this is going to really confuse the crap out of you if it hasn't already. All right. So let's take a look at this overloaded method. Remember we talked about overloaded methods. The difference between a regular method and an overloaded method is a regular method only has one signature. A method signature means the type of parameters, if any, that the method has in its header, right? The definition of the method. Here there are two definitions. One that has nothing, and the second one that takes a parameter of type string, right? So there's two methods, two constructor methods. So these are considered overloaded constructors, right? Because there's two different ones. Now, if I decide as a user, I have two choices now. I could not assign any name by using the empty constructor, or I have an option of setting the name directly. Let me show you what I'm talking about here. So if I go down to here now, and if I define a new person, see how the new person's been defined. Notice how when I hover over it says +1 overload. When I define the new class, I can do it like this, and it gives me a little bit of intelligence now. I can do person with the empty constructor or person with that takes a string. Either one will do. It'll work either way. Let's try this. Let's add a constructor, like a name in there like this. So Tom. Okay. And if I don't set this up, so we're just going to kind of do one of those, right? Comment it out. Notice how we're not using the default constructor anymore, the empty constructor. We're using the second constructor. So because we're setting a value, the first constructor doesn't trigger. Only the second one does. Because this is the only constructor inside of our class that takes a string as a parameter. The other one does not. So therefore, it never triggers. Only this one in this particular case. Now I can create different instances of the person class, some of them that use the empty constructor and some of them that use the constructor with the string that takes name. Both are valid because they're two different options for me. All right, let's try this out. So now I should get person.name is equal to Tom, even though we've only set it here in the constructor. Well, how does that work? Because name comes into as a parameter into this person constructor, this version of the constructor, and then it gets assigned to the field that we've defined as a data field inside the person class. Okay? Okay. So today, what I want you to do is look at a couple things. Let's go over here and look at week 3. If I look at week 3, I have my PowerPoint. Please, if you haven't had a chance to read it, go through it. It's going to help you, number 1. 2, under Dropbox, and this is a little assignment for you for this week. It's a little lab. It's worth 2% of your final grade. There's something called objects and classes. Let's take a look at what the details are of the lab, right? If you look at the details, you can see that there's a few things I want you to do, right? Now, it looks like a lot, but actually it's not really a lot. It says, create a program that defines a simple person class. Well, we've done that already, right? Ensure the person class is defined in a separate file. We've done that too, right? If you follow along with me, you're halfway, you're there. The person class should include the following private instance variables, right? It has a name. We didn't do the age yet. We will, right? The person class should include the following public property, name, which we've done, right? The person class should include the following public methods, say hello and show age. We haven't done that yet. And then ensure that all private instance variables start with an underscore. They do, right? So we've got that piece done. Ensure all public properties and methods start with a capital letter. So far, they do, right? And then the person object will call a say hello method, which it hasn't done yet because we haven't defined it yet. And the person object will then call its show age method, which we haven't defined yet. Ways of submitting your work: submit a zip archive of your files to the Dropbox and submit a link to your repo on GitHub. If you do all that stuff, 2% of your final grade by this Friday, the 27th of May, by midnight. Lots of time and you're partly there, right? You want to skip ahead and try it all before we get together next class? I highly recommend, right? Because it'll make it easier for you to understand if you make mistakes. Guys and girls, this is a perfect chance to make mistakes. Then I can come and help you and correct them. Tom, it doesn't work. Or this is what you want. Show me, Tom, right? So that when we get something bigger, and then I'll leave you with this thought, right? Because I want you to talk about your, we're going to talk about the assignment again. But let's go back for a second to Dropbox and look at that assignment. The assignment's bigger. It's called the hero class. We're going to make a superhero. First, we're going to make a hero, and then next week, or maybe the week after, we'll make a superhero, right? Let's take a look at this. So in the folder, I have a file called Assignment 1, the Hero Class PDF. Let's quickly take a look at that. More complex. Here I define what the class should be for private and public properties, private instance variables, public properties, private methods, and public methods, right, that are here. More complex example, but you can't get to this unless you do your lab, right? This is due next week, Friday at midnight, right? Not a lot of time. Why? Need to get this stuff as soon as possible. The faster you get objects and classes, methods, all that kind of stuff that are part of classes, the more we can do afterwards, right? So please read the assignment. It generates a hero. And the hero, what he can do is he has some properties, like he has strength, speed, and health, right? Think about what he can do. And he also has a name. Notice that the name is a private name instance variable that we set with our public property. Guys, and girls, you've only done this one. So I've hit 2. I've hit the person class with your lab 2, and I've hit your assignment 2, but your assignment 1 with this little example we did together. So you're kind of halfway there. You're getting there, you know, with some of the stuff that we're getting. So this is all due by next week. We're going to go over it again, but take a look at what my requirements are. Each line, because you haven't done an assignment with me before, tells you what you need to do. Like example, the hero class must include the following properties and methods. Private instance variables, strength, speed, health. Okay. How do I define private instance variables? I need an underscore in front of the name. So underscore strength, underscore speed, underscore strength, health, right? They got to be int, and int, 3 ints. And then underscore name, because it's a string, right? 3 marks for functionality. If you do these 4 things, you get 3 marks. Each line tells you where you get all your marks for this assignment, right? So it's very clear on how I'm going to mark you. Also, up on Blackboard, Dropbox, same thing. I'm going to be I have a rubric that's already been defined, right? So when I mark you, you're going to see where your marks are coming from. 26 marks for functionality, 4 marks for program structure, 6 marks for internal documentation best practices, and 4 marks for version control, right? So every piece of it. So part 1 is all about your functionality. Part 2 is what happens in the main driver class to test everything out. Part 3 is your program structure, how I want you to structure everything. Part 4 is your internal documentation. Part 5 is your GitHub. And there's some optional program features. Guess what I'm making optional? Unit testing. So if you do your unit tests for all of your methods, bonus points. I'm going to give you 2 bonus points for every unit test you create that's successful. So there's a great opportunity here for if you did some, you didn't do so well in your test, your little quiz, you didn't do the quiz somehow, right? Or if you didn't do great in your lab, one of the labs or the other lab, you can fix it up and get bonus points. But if you did great in everything, you can have some bonus points that carry over, so you can get 100% in the course, which is I want you all to get. I told you before. I want each one of you to get 100%. Here's another opportunity for you to make up your mark to get higher marks. Okay. So please, the rubric, a little shortened version of the rubric is right here for you to look at, right, to tell you where all the marks are. Remember that it's worth 10% of your total mark for the course. Late submissions, 20% each day. So if the first day, if you don't hand it in by Friday next week, Saturday, you're working at a 80. Sunday, you're working at a 60. Monday, you're working at a 40. Might as well not hand it in after Monday. So Monday is closed after that. After that, just to fail anyway, right? So please try and get it in on time, right? Any questions on this stuff? We're going to go over it again Friday. So when we meet together on Friday, right, we're going to continue with this scenario. I'm just going to upload to GitHub right now, so we have everything on GitHub so you can check it out, right? So I'm going to go to Team Explorer. I'm going to go to Home, and I'm going to go to Changes. You can see that I've made a couple changes to my person and program classes. I'm going to add them all to the staging area. I'm going to say updated, person class include name property and 2 constructors. That's what I've done. And commit staged, home, and sync. Anyone have any questions before we depart? We have about a minute left. Yes. Oh, you have a personal question? All right. Anyone else have any questions about what we've talked about today? So, okay, so this is what I want you to leave with then. So remember that classes are blueprints. right? They're a plan for our objects, right? Objects are physical, almost think about them as physical things, concrete things that I can deal with, right? Can't make an object without a class. A class has private instance variables and public properties, and also has some private methods, we haven't talked about that yet, and public methods, right? And it enables, it almost creates what we call a custom data type that we can define, and we instantiate objects with the new keyword. Okay, those are the things I want you to take away from this one. Guys, see you Friday.